So the next project is from a group at Hopkins. The PI is Russ Taylor, colleague of mine, and actually a true pioneer in medical robotics. The talk will be given by Peter Katsantsides. He was actually Russ' postdoc at IBM Research, but is meanwhile a professor of computer science at Johns Hopkins. And today he will talk about innovative safety measures in the ICU with telerobotics.
Right. Hello, I just started the screen share, so yell if you don't see it. So yes, I'm Peter Katsantsides from Johns Hopkins, and I'm giving this presentation on behalf of my colleagues Axel Krieger and Russ Taylor, who are also both on this call. Let me minimize this so I can see my own slides. So the problem is that if you look at the image on the left side, this is a photo from the ICU at the University of Maryland Medical Center. In order to go in to change any settings on the, in this case, ventilator, that's what's pointed to by this red arrow, healthcare workers would need to put on the personal protective equipment, even if they just want to, press a single or a few buttons on this ventilator. So one solution they've come up with on the right, this is also from University of Maryland, is bringing the devices actually outside of the ICU. In this case, the infusion pumps, running long tubing into the ICU. The disadvantage of this is, you don't need to put on PPE to go press the buttons, but if you actually are in the ICU and want to make a change, you can no longer do that. So the obvious long-term solution here is a network-based monitoring and control of these medical devices. But then the question is, well, what can we do in the short term? Now, I've given away the answer with the title of my talk, or at least our proposed answer. But first, I want to talk a little bit about the design process we went through. We actually started with a number of meetings, virtual, of course, with healthcare workers and other specialists. And this included, ICU doctors, nursing professor, respiratory technician, and the Hopkins Institute for Patient Safety and Quality. We talked about a number of different topics and ways that robotics or other types of engineering could help. And this is just one of the projects that spun out of that. And so, as I mentioned, the proposed solution is telerobotics. So the idea is you would have a healthcare worker outside the ICU looking at an image of the screen or the interface of the device. And the idea is that pressing a button here would cause the corresponding robot in the ICU to press a button. Here we're showing an infusion pump, and here this would be a ventilator touchscreen. So some of the system requirements that we got from the users were, some fairly obvious ones about being easy to set up and operate by healthcare workers, not by robotics engineers. Another key one I want to point out was that the feedback we got is that it really needed to be efficient. They didn't want to have to go and teleoperate the robot, move, left, right, up, down to get to the button and then say, okay, now press the button. They really wanted high-level control. I click on a button here, the robot presses the button there. So these are two of the design concepts that we're developing. On the left is a Cartesian robot shown here. This has the advantage you can directly attach it to the touch screen for devices that have a touchscreen interface. It has, of course, quite accurate motion, but it can be a little more challenging if the interface or if the device is differently configured. For example, a curved surface with actual physical buttons. On the right is the idea of using a low-cost robot arm, which also has the advantage that if you mount a camera on it, you can survey the room, which some of the healthcare workers thought would be useful. But some challenges here would be, how do you mount this to near or on the device? Also, it's likely to have a less accurate motion. So this is a video from Axel Krieger's group showing the first prototype of the Cartesian robot attached to a computer screen. This is not being teleoperated. In this case, there's a little program and you click somewhere with the mouse and the robot moves there, but it shows the basic concept of being able to take a 3 degree of freedom robot and interact with a touch screen. On the robot arm, development. We've actually purchased a low-cost educational robot. This one was $200 on Amazon. And we're now working on making it more of a real robot in terms of things like ROS interfaces and other sort of robotics capabilities. As I mentioned well, I didn't mention it, but on one of my slides, we talked about not damaging the medical devices. So we're also working on a compliant finger that would give us the opportunity to do some force sensing. And on the right just shows another possible configuration of this robot to try to improve accuracy. So I'm going to wrap up. I actually forgot to start my timer, so I'm not sure if I'm running short or long, but we've developed these two concepts for in ICU device control, working on prototypes. We're looking to get some support for further development and deployment to the hospital ICU. And our goal, I think somewhat ambitious, is to try to test the Cartesian robot to control a specific ventilator that has just a touchscreen interface in July. And then follow up by using the other robot to control the infusion pump in August. So thank you for your attention.